concentration, concentration, concentration. So we want to see how change in concentration can alter equilibrium, and how equilibrium could negate this change in concentration in order to restore itself. So let's look at a typical reaction at equilibrium. I will want to, let's take a reaction between, let's say, let's just take nitrogen reacting with hydrogen, okay, to give us ammonia. Okay, this is an equilibrium reaction. This is an equilibrium reaction. You can see that. But this reaction is gaseous. That means the reactant and product are gases. So, and because they are gases, really, we may not be able to talk about concentration because they are not dissolved in solution. Okay, so, but this is an example of an equilibrium reaction. Okay, so when we want to talk about temperature and maybe pressure, we can use a gaseous system. So let's look at another example, or let me just go ahead and use this as concentration. So let's just assume that these reactants and products are in solution. Otherwise, we could have used the example of, let's say, methanol, okay, that's plus ethanoic acid. Okay, so let's just use this so that we'll get it in the right perspective. Okay, methanol plus ethanoic acid will give us what? Can you still remember your organic? It's going to give us what? Methylethanoate. Yes, plus water. Okay, so this will be a good, this one we can talk in terms of concentration now. Now, if you look at this reaction, it's at equilibrium. We have reactants and what? And product. So we want to say, okay, so if we increase, let's say increase concentration of, let's pick any of the reactant, concentration of methanol, what is going to happen? Because that's the first thing. We have altered the equilibrium. This system was at equilibrium. Then we alter the equilibrium. We change the equilibrium by increasing the concentration of methanol. So the question is, so what will equilibrium do in order to restore itself? So we can describe what equilibrium will do in terms of saying equilibrium will favor a certain, direction, or you say equilibrium shifts towards a particular side. Do you understand that? Then we'll talk about the implication on yield. That is the amount of product or reactant that is formed. So let's look at this together. Increase in concentration will do what? Will cause what? Equilibrium. In order to restore itself, equilibrium will shift to which side?
To the side with less concentration.
With less. Okay. So basically, now we have, this will be your products now. Basically, this will be your product for the forward reaction, and this will be the reactant. So if you increase the concentration of any of the reactants here, what equilibrium will do is that equilibrium will use the reactants to form more product. That means that equilibrium will shift to the what? To the right. Can you see towards the right hand side? Equilibrium shifts to the right, shifts to the what? To the right hand side, shift to the right. Or you say equilibrium favors what? Favors the forward what? The forward reaction. That's the forward reaction. This is the forward reaction, X. The backward is Y. Equilibrium favors the forward reaction. And if this happens, what will be the effects? The effect is this, that more what? more products will be what? Will be formed. That means more CH3, COO, CH3, and what? And water will be what? Will be formed. Will be formed. So we say increase in what? In yield. You have been hearing the word yield. Increase in yield. More of this will be what? Will be formed. Increase in what? Increase in yield. More of this is what is formed. Increase in what? In yield. So let's look at a twist to that. The same thing will happen to if you increase the concentration of what? Of CH3COOH, which is your ethanoic acid. The same effect will happen. So let's go to maybe decrease the concentration. Let's just say decrease in concentration of decrease in concentration of CH3, COO, CH3. Can you predict what equilibrium will do? If you decrease the concentration of CH3, COO, CH3, methyl ethanoate, what will happen to equilibrium?
So will it go to the left? No. So will equilibrium shift to the right because they're trying to increase.
All right, equilibrium will shift to the right. Okay, the same effect that we had here is the same thing that we are going to have for this one. Can you see that? If you decrease the concentration of your product, okay, more of the product will be formed. So equilibrium will shift to favor the forward reaction. If you increase the concentration of the product, so let's make it a twist now. Let's say increase, if you increase concentration of methyl ethanoids, let's say you increase concentration of this, where will equilibrium shift to? Where will equilibrium
So it will shift to the left.
will shift to the left? So you say equilibrium favors the backward reaction. Equilibrium favors the backward reaction. So there will be more yield of what? Of methanol and ethanoic acid, and there will be less of what? Methyl ethanoate. Okay, less of methyl ethanoate. So if you increase the concentration of this, equilibrium favor. So you can just choose which language to use, which expression. Equilibrium favors, you say equilibrium favors what? The left. The equilibrium favors the left. Okay, yeah, that's what's going to happen. So that is how change in concentration affects the what? Affect the position of what? Equilibrium. So let's look at concentration is easier to understand. So let's look at